All right, so we're gonna move into the time domain now. Basically, the simulations that we've looked at so far have been .op or operating point simulations, which work for DC circuits. They basically show us a specific what they call operating point. I use air quotes there, which means that we're looking at one instance in time. There's no time dependence in the circuit. It's really just looking at the voltages and the currents, kind of like a snapshot. Or in DC circuits, because they don't change, we could be looking at them at any time, and it doesn't really matter because DC circuits, by definition, the voltages are constant, the currents are constant, nothing is changing. And so, what we're going to be looking at next in these tutorials, I guess these are kind of like tutorials, is transient, what they're called transient simulations, and that just means that they are time dependent. The voltages are changing with respect to time. The currents are changing with respect to time. Um, the first order circuits that we learn in this RC circuits and RL circuits module are transient response. Transient responses are really what we're interested in. The response of the circuit over time at a specific point in time, of course, because beforehand nothing interesting happens. Afterwards, nothing interesting happens, and at some particular uh, span of time, we're interested in knowing what's happening. We want to see the behavior of the voltage or the current, for example, and where it all really begins is the source that we use. So what I want to show you first is the source. So it's just a typical voltage source like we've been using, but instead of just putting a DC value here, we're actually going to go ahead and two-finger click or right click if you have a mouse right on the voltage source, and then there's this button that says advanced, and we're going to click that. And so you can see that the style of the source has a little drop down menu, and we've been just using the DC value. That's the equivalent of me just putting 3 volts here and hitting OK, is the equivalent of just editing this field. I'm going to go ahead and undo that, go back and hit advanced, and then I can see this drop down. There's all these different types of sources. There's pulse sources, there's sine sources, which is a sinusoid, exponential sources, which give exponential behavior. I'm actually not sure what this one is, but these two are both piecewise linear functions, and so there's all kinds of different options for the source that we can use in transient simulations. The one that we're going to talk about first is the pulse source. When I click on pulse, it gives me all these options for how do I want to set up my source. What voltage do I want it to start at? What voltage do I want it to finish at or rise up to when it pulses? How long do I want that to take in order for it to rise up? Or actually, sorry, how long before I want the process of the rising up to start? Then, how long do I want the voltage to take to rise up? How long do I want the voltage to take to fall? How long do I want it to be at this on level? That's what T on is. And then you can make it periodic by messing with the period and the number of cycles. Okay, so this is what a pulse source does. And when I put it here, it kind of just doesn't have any of the fields filled in because I didn't fill in any of them. And so what I'm going to do in subsequent videos is I'm going to kind of go through and make some changes to some of these different fields here so that we can get a better understanding of what each one means, just so that the pulse source is pretty, it's not a mystery to you why. I mean, we're going to basically be using it for very simple on and off kinds of things in these RC and RL circuits, but I want to make it pretty clear what the other parameters are doing to the actual waveform. Okay, so I'm going to go ahead and stop this video. Just wanted to introduce the pulse source, and in the next video we'll go ahead and actually run a transient simulation with some of these parameters filled in and kind of start talking about what we're actually doing when we mess with these parameters for a pulse voltage source. Okay, so I'm going to go ahead and end this video.